Greetings, AP Chemistry students. In this video, I'm going to go through some more practice with balancing and analyzing redox reactions. I know that that's not necessarily the easiest thing to do, but you are going to want to make sure that you have handy a copy of the rules that we went over yesterday for assigning oxidation numbers. So as we analyze this first reaction we've got here, there are some elements that are easier to balance than others. For instance, if you have an element by itself, its oxidation number is 0. So sulfur right here, that's a big 0. It goes by itself. Then we learned that unless it's bonded to a metal, hydrogen is going to be a positive 1. Then oxygen is usually a negative 2. So that works out in the water. And there and there. And so now we just need to figure out through process of elimination what these other ones are. We've got 2 hydrogens at positive 1. Sulfur must be a negative 2. If oxygen's a negative 2, nitrogen must be a positive 2 in the NO. And then in HNO3, we have 3 oxygens at negative 2, so that's negative 6. And then we have a positive 1 from the hydrogen, so the nitrogen must be a positive 5. So if we look at this, the things whose charge change are sulfur and nitrogen. Because sulfur's charge is going from negative 2 to 0, and nitrogen is going from positive 5 to positive 2. So if we take a look at this and we try to figure out what is oxidized, keep in mind oxidation is losing electrons or becoming more positive, that would be sulfur, which has lost 2 electrons. And if we look at what is reduced, that would be nitrogen. It gained 3 electrons. If we were to try to write some half reactions for the basics of what's happening here, we have sulfur with a negative 2 is turning into just plain old sulfur, solid sulfur in this case, and it has lost 2 electrons, so on the product side, we're producing 2 electrons. Then we have nitrogen, which is going from a positive 5 to nitrogen with a positive 2 charge. It's gaining electrons, so we're going to add those electrons in as reactants, if you will, to balance the electrical charge here. And then you'll notice that we have 3 electrons and 2 electrons. Those are not equal. We need our electrons to be equal to each other. So we're going to take this, and the least common multiple between the 2 electrons and the 3 electrons would be 6. So we're going to triple the top half reaction, and we're going to double the reduction half reaction. So that means our sulfurs need to be tripled. Our nitrogens need to be doubled. And then we just need to take a look at our hydrogens and oxygens and see how they all fit into here. We have 6 oxygens on the left side. We've got 2 plus, we're going to try 4 right there. And then that's 8 hydrogens on the right-hand side. And on the left-hand side, we have 6 plus 2, which is 8 hydrogens. It all works out nice and beautifully. For the second reaction, we're going to do the same process. Because this reaction, if you just tried to balance it by itself, if you just said, I'm just going to balance this reaction using my traditional balancing equation rules, you would say, well, we've got 4 oxygens on the left, so we'll put a 4 right there. That gives us 8 hydrogens, so we'll put an 8. And then we've got 2 chlorines on the right and 1 on the left, so we'll put a 2. That would be what you would come up with, and that would be wrong. So let's look at how we're going to actually do this by paying attention to charges. So first, we need to assign oxidation numbers. So we've got some easy ones. Chlorine, it's an element that's just chlorine, it's a 0. Manganese has a plus 2 charge, so it's a plus 2. The chlorine with a negative 1 charge is minus 1. Hydrogen with a plus 1 charge is plus 1. Oxygen's usually negative 2. We have 4 oxygens at negative 2, so manganese must be a plus 7 so that it equals -1. And then over on the product side, in the water, hydrogen is a +1 and oxygen's a -2. So if we analyze this to see what is oxidized and what is reduced, we'll notice that manganese goes from +7 to +2. So the charge is going down. That is reduction. So that's manganese. And reduction is gaining. Remember oil rig. Reduction is gaining electrons. It gained 5 electrons. And then the thing that is oxidized is the chlorine. It's becoming more positive, going from -1 to 0. And each chlorine gains 1 electron, which might seem simple enough, but let's try looking at some half reactions here. We have Cl minus turning into Cl2. I'm sorry, why did I say gain? Chlorine lost 1 electron. I know better than this. All right, so chlorine is going from Cl minus to Cl2. The first thing we need to do is balance the chlorines by putting a 2 right there. And then, since each chlorine is losing 1 electron, but we have 2 chlorines doing this, we're losing 2 total electrons. So the electrons being lost will be on the product side because they're left over. They're extra electrons, essentially, from this half of a reaction. And then the thing being reduced is manganese. So manganese is going from a +7 to manganese as a +2. And to do this, it's gaining 5 electrons. So we'll put those on the reactant side. And then, in order to balance this equation, to add these half reactions together, our electrons need to be the same on each side. We can't have extra electrons being gained or lost. So we need to get the least common multiple of 5 and 2 is 10. So we need to multiply the top half reaction by 5, and the bottom one by 2. So for the manganeses, we'll put 2 and 2. And then for the chlorines, we're going to need 2 times 5, or a 10, and a 5. And then we've got 8 oxygens on the left side, so we need to put an 8 right there, and then we need 16 hydrogens. And now we have balanced everything as far as charge is concerned, all that good stuff. And even just overall charge is conserved as well, because on the left-hand side, we have 10 -1 charges, so that's -10. We've got 16 +1 charges, so we're at +6 overall. And then we have 2 -1 charges. That makes us overall charge +4. And then on the right-hand side, no charge, 2 +2 charges, +4 charge on the product side. So all the charge is conserved, all the electrons are conserved. This is nice and balanced.